So let's look back at our function again. At time 0, I would have the number 1.34 to the exponent 0, which would equal the value of 1, so I would just be left with 0.45. So that means at time 0, there was approximately, because this exponential function is approximating my data, 0.45 of an inch of snow. I can also go down here and verify that by substituting in the value of 0, and it returned a value of 0.45. Let's look back. My growth factor is 1 and 34/100ths. This means that the snow is growing at a rate of 34%. So it's an exponential growth of a rate of 34% every hour, because time was in hours. Now I want to see at 24 hours, which is way over here, my graph doesn't even go up that far, approximately how much snow I would have. So again, I can use substitution, put in 24, and it gives me my approximate value. So after 24 hours, I could have, if it continued at this rate, 469.335 inches, which would be a lot of snow. So I don't think it can continue growing at this rate. And that's an example where this model would not be an accurate model to use for the snowfall at 24 hours. This is just not a reasonable number. But that's what it is according to this model. Last we have to look at is how much time would it take to reach 30 centimeters. So I can see 30, not centimeters, sorry, inches. This was a US video. 30 inches looks about at 14, so I can guess, do some trial and error and say, let's see, f of 14, that's pretty close right there. I could try another one, say f at 14.2, getting a little closer. Or I can go and use some logarithms. So I know that my f of x value should be 30 inches. So I'm going to set that equal to 30. This is what my equation would look like. 30 equals 0.45 times 1 and 34/100ths to the exponent x. Now, if I divide both sides by the 0.45, I'm ready to take the logarithm of both sides. Using logarithms, I would have the log of 30 over 0.45 to the base of 1.34. And I need to find the logarithm of that. So I'm going to go into an online calculator, Web 2.0, and say I want the log base 34 of 30 divided by 0.45. Notice I've written this here, and so that's not correct. I've got to change the order here. So my base comes after. This is correct. Log base 1.34 of this value and equals, so it's approximately 14.34 hours. So about 14 1/3 hours to reach 30 centimeters. If we look back at the graph, we did say, remember, it was close to 14 because we had tried those two values, 14.0 and 14.2.